We often view life as a fragile layer existing on top of the Earth, a passenger at the mercy of vast geological cycles. Modern Earth sciences have shifted paradigms, identifying life as a structural gear within the planetary engine. This holistic system functions through four subsystems locking into one another: the geosphere of rock, the hydrosphere of water, the atmosphere of air, and the biosphere of all living organisms. This interconnectedness raises a mechanical question. How does physically fragile biology possess the power to weather mountains, shift the chemistry of global oceans, and rewrite the sky's composition? Answering that requires tracking the specific ways biological processes function as a significant geological force. Biological weathering begins at the root. Plant systems, burrowing animals, and acidic lichens actively fracture and dissolve solid stone, grinding the geosphere into smaller fragments. Broken rock mixes with bacteria to build organic O and A soil horizons over deeper parent material. Over deep time, layers of biological debris are compressed into massive limestone and fossil fuel deposits that make up the Earth's crust. These deep rock layers act as a library. Index fossils, like these trilobites, serve as timestamps, allowing geologists to date strata and track mass extinctions. Recording this history requires rapid burial in anoxic environments, places without oxygen, to prevent decomposition and allow the geosphere to preserve the record of the biosphere. These deep sedimentary layers prove that the very ground we walk on is a recycled graveyard of past ecosystems that actively constructed the lithosphere. This biological architecture also reaches the hydrosphere. Soil composition and root structures dictate how much water seeps into the ground versus how much runs off, directly influencing regional flood control. The atmosphere shows a similar transformation. The Earth's primary atmosphere was a toxic mixture of gases emitted by volcanic activity. Continuous photosynthesis and respiration scrubbed these gases to balance oxygen. This massive influence is driven by the food cycle. Solar energy enters through producers and moves upward to consumers, but transfer is inefficient, losing 90%. While the oceans and atmosphere act as massive long-term sinks that eventually regulate these chemical spikes, that process moves at a geological pace. The biosphere, however, reacts in the short term. Even temporary, minute changes in air and water chemistry can cause terminal shocks to fragile ecosystems. Survival in a 21st century context depends on recognizing that human activity is subject to these cyclic natural laws of matter and energy. Maintaining the biosphere requires respecting the deep physical connections it shares with the rock, the water, and the air.